Great. And so David in the chat asked, I'm new to RAD-seq analysis. So I've looked at one way to deal with missing data is fill it in with the consensus in the loci. Do you recommend this approach?
Well, so much silence.
I mean, I would generally not recommend this approach just because it seems like somewhat arbitrary. I guess it depends on what analysis you're doing. It seems like it would just introduce, you know, it's trading one problem for another problem, right? So I probably wouldn't recommend that strategy overall. I would recommend probably having, you know, dealing with the missing data directly rather than trying to like hotwire it. But
I agree. I would not recommend it.
Yeah, me neither. I think I'm trying to recall it. I remember a colleague arguing about doing it because he was doing this for phylogenetic purposes, and he had some very precious samples that had high missing data. For some analysis, I think he really needed to do not have missing data, and feeling the consensus was like the only option to keep it and to be able to include it in a phylogenetic analysis. So I think if you're in that situation where you really don't want to discard that sample, it's okay. But I think there are other methods, even phylogenetic, that can allow for missing data. So yeah, I will also not recommend it.
I mean, I think that kind of piggybacking on what Alicia was just saying, I think that if you do have these precious samples, you know, I would, rather than just filling with the consensus sequence, you know, what I was saying earlier is adopting kind of like a resampling procedure where instead of just picking the consensus or the, you know, the most frequent allele, you just resample over the alleles given the frequency within the population, and then do replicate analysis, and then combine all the analyses into kind of like you know, like a meta-analysis or something. So that would at least be a way of kind of averaging over the, you know, the probability of you know, any given allele at any given site without biasing, kind of based on the consensus. That's a lot of work.
I think you can also, there are some Bayesian approaches using genotype likelihoods rather than straight up genotypes that can help with missing data. I haven't used them personally, but like free Bayes is one that I think a lot of people use. So that might be something to look into if you have some missing data and, like Alicia said, you like really can't discard some samples that you need for analyses. But I would, as we've mentioned a couple times, suggest running the analyses with and without those kind of modifications and seeing what that does to your data to make sure it's not doing something that's problematic.
So yeah, as Danny just pointed out, some analyses like PCA, at least as it is in AdaGenet and R, they can't handle missing data. And so like I have the way that I fill that in, but it'd be interesting to hear how you guys deal with missing sites for PCA. Or are we wrong and it does allow missing sites and we've been doing it wrong?
Yeah, I don't know. Last time I checked, I was just like, it wouldn't work or whatever, but I haven't used it for a long time. I'm just thinking when I was a beginner, that's something that, oh, I will use this. And so I'm just wondering, yeah, about that.
I think that, I don't know how any given specific package works. I haven't used AdaGenet in a while, but I do know that for PCA, for a lot of different methods, it's not that it doesn't accept missing data, it's just that it codes missing data as the ancestral state, kind of without telling you, right?
Right.
So this is kind of dangerous in a different way because it gives you, you know, it'll spit out a result, but if there's a ton of missing data and it just codes it all as ancestral, then you're going to get a result that isn't meaningful, right? So yeah, I mean, for there's different strategies, but yeah, like the resampling procedure I found works really well with PCA specifically. And if you can go and look at the example notebook for PCA where I show you how you can do that in IPyRAD, you can see that I think that that's one kind of nice way of handling it. You can implement this in AdaGenet too, but just, I don't know how to do it out of the box, but I'm sure you could do it.
Yeah, it was my belief that in at least in AdaGenet, that when you do the PCA and there is missing data, the allele frequency is filled in by the mean of all samples. So essentially it's biasing everything to kind of cluster back into that center. So if you're looking for structure, it's at least, biasing you in the good way, I guess, or the more conservative way. So that's probably what that's the way I would approach it, is doing iterative different missing values cutoffs and seeing if it's changing your results.
One I'll just mention also is I have done PCAs where for each pairwise comparison, it only uses loci those individuals share in common. So I'm kind of still thinking about what that means, what the PCA is if you're not using only shared loci across all the individuals. But I think that's problematic if you have very, very high levels of missing data where it's like completely different loci are being compared among all different pairs. But I think in that way, you're not filling in that missing data with any population mean or something else. And so it would be great if someone could do a paper on that, looking at what happens if you just look at basically complete cases in the pairwise comparison. So only looking at loci that individuals both have data for.
And Malin Pinsky just pointed out in the chat that the low coverage sequencing community has thought hard about what to do. And there are packages like PCAngst that work specifically thinking about what to do when you have a lot of missing data. That's a great point. And so a question from Andrew. One of the thoughts that CD-HIT has provided is that sometimes it might be better to use hierarchical clustering. Is this something that you have used and found useful? Do you see certain conditions or experimental designs where a hierarchical clustering approach might be useful?
So I'm probably the one who's used CD-HIT the most, so yeah. I'll take a stab at this one. So the hierarchical clustering is somewhat new in there in CD-HIT's methods, and I do think that, especially in a multi-species framework, like if you're trying to do a multi-species type of reference, then the hierarchical clustering might be something that could be useful, and perhaps helping to deal with some of those paralog issues that Alicia was mentioning earlier. I think some of this is, it's hard to say, I think, from a de novo and like blanket perspective, like how it might help. And I could probably imagine certain situations where it might help and others where it would not. And some of this, I think, is avoided if you are taking subsamples of your data to do assembly. If you are throwing everything in there, then I think the hierarchical clustering probably works really well and is necessary to some extent, but it's not something that I've really played around with a lot, so I couldn't really give you a great specific answer about that. And Andrew's already asked me this question before, so.
Yeah, and Bailey Carlson actually has a question that I was on my list and wanted to get to, so I'm really glad that they asked it. And essentially, it's about what is the future of RAD. Whole genome sequencing has become a lot more popular and cost effective in many ways. And so, but as they say, RAD-seq can still be cheaper at times, and getting a grant as a grad student, maybe you don't have money for a really big whole genome seq project. And so with, cost and utility in mind, and maybe also utility for different species that have really different genome qualities, like where do you see the future of RAD in 10 years? Will we still be using it? Will we have moved on?